All right, let's take a look at these extra credit factoring. Okay, I just really want to quickly want to mention, why are we factoring? Why would you want to factor something? We factor stuff because we want to find the horizontal intercepts. Right? If here's our graph, and here's x and here's y going up and down, if you want to find where y equals 0, you need to get those factors. Okay, so if we come up here, we factored. Oh, I took the work away. It's erased. But look, I get in this number 9. We had to factor the standard form to get the factors to find the zeros. So we're gonna factor this. Sometimes it's a little bit easier when you don't have this some number other than 1 out front there. Okay, if mostly we've been practicing factoring, just starting with a leading coefficient of 1 is the way the mathematicians say it. So it's just got a little bit more complicated when we've got like a 2 out front of the x squared or some other number. But that's why I made this extra credit for you. So let's take a look at this. Here we go. So I've highlighted 2 and 10 in purple. Those, we need to multiply 2 times 10. That's going to be 20. So why did we multiply those together? We're looking for two numbers that multiply to be 20. And then in orange, I'm going to write a plus b equals 9. Because we need those same two numbers that multiply to make 20, we need them to add up to be 9. And this, when you're doing the factoring with this lead coefficient that is not 1, it's something other than 1 out here, you're going to do it like this, factoring by grouping. Okay, so now what we're going to do is we're going to find what the factors are of 20 so we can see which ones add up to make 9. So we start off by taking 20, the 2 times the 10, and thinking of the factors. It could be 1 times 20, but that adds up to be 21. It's not 9. It could be 2 times 10. That adds up to 12. It's not 9. And then we got 4 times 5. 4 times 5 equals 20, and guess what? It also adds up to 9. So here's my little box with my factors. I'm going to highlight in orange these two right here are the ones that I'm looking for. So now what we're going to do is we're going to break up that middle term, that 9x. I'm going to change it into that 9x into a 4x plus 5x. So down here I'll write 2x squared. And then I'm going to take that 9 and I'm going to break it up into a 4x and a 5x. And then we got the plus 10, right? Okay, so nothing has changed. Basically, all I did was change that 9x to a 4x plus 5x. That's really all I've done so far. Now, I remember in high school thinking, oh, what happens if I put the wrong one in the wrong place? What if I move this one? What if I put the 5x first and the 4x in the other spot? It'll still work out the same way. It's going to work either way. I personally try to put stuff that looks like it goes well together. Like I know the 2 and the 4, they both have that common factor of 2. I know 5 and 10 have the common factor of 5. But it will work no matter which way you put this. So don't stress too much about that. Okay, so now what we got 2 groups. We got 2x squared plus 4x, and we got 5x plus 10, and we need to pull out the greatest common factor, GCF. My greatest common factor. So when I'm looking at this one right here, look, I can divide 2x squared by 2, and I can also divide 4x by 2. I could divide 4x by 4, but I can't get a 4 out of that 2, right? So a 2 is the biggest common factor of the 2 and the 4. And then I got to think about this x squared and the x. I could pull an x squared out of 2x squared, but I cannot pull x squared out of 4x. So all I'm going to be able to get is the 2 out of both of those, and I can pull the x out of both of these right here. So let's factor 2x out of this first pair of terms here. 2x squared divided by 2x is just x, and 4x divided by 2x is just 2. Oh, the stinking ruler just won't leave me alone. Okay, now I'm going to double check my math, okay? You might make a mistake, so make sure. Is this, when you distribute that 2x, are you going to get this up here? 2x times x is 2x squared. And 2x times 2 is 4x. So far, it's looking great. Now, here's my other pair. What's my common factor that I can pull out of 5x and 10? There's no x over here, so I'm not going to be able to divide both of those by x. So the x is stuck right there. I could divide this by 10, but 5 is not divisible by 10. I don't want to deal with a 1/2. Okay? I'm trying to pull out the greatest common factor where I'm going to leave a whole number. So we're not going to divide everything by 10, but I can take a 5 out of both of those. So there's as much as I can pull out is that 5. So now I'm thinking 5x divided by 5 is x, and 10 divided by 5 is 2. And looky, what do you get right here? We got these matching x plus 2's. These guys go together, and they were hidden in here. And we just pulled this 2x and the plus 5 out, and now we got these common factors. So you could say this 2x and this 5 have this common factor of x plus 2. I can divide this expression by x plus 2, and I can divide this expression by x plus 2. So it would make more sense for you guys to just write it like this. Pull out the x plus 2, divide that first term on the left by x plus 2, and you're going to get 2x. And then divide this term over here on the right by 5. We get plus 5. And you could switch those up. It doesn't matter which one you write first. It's the same thing. Guess what? 2x. If you multiply these together, first outer inner last, 2x squared. I got the 5x plus the 4x makes 9x, and the 2 times 5 is 10. This is right. That's how we factored this thing. And if you were trying to find your intercepts, this would help you, because then you'd know that when x is negative 2, y is going to be 0. And when x is negative 5/2, you get a 0. But I'm not asking you to do that. I just want to see if you guys can factor by grouping for extra credit here.